Okay, are we back? Are we back? Are we back? Are we back?
Yes.
Thank you, Elsa.
Yeah, I'm back.
Thank you, Erica. Mark, are you back?
Yep.
Kathy?
I'm back, Professor.
Okay, very good. Let's keep it going. I hope Kathy's back, but we're going to keep it moving. So, again, the cost of manufacturing bikes at a plant is given by a function. C of x, that's like the cost function. 2x squared minus 800x plus 92,000. We find the number of bikes that must be made to minimize the cost. What would be the cost? Okay. So to answer any question like this, the key word is minimize. The other key word would be, if you see this word, maximize. Those are your keywords, minimize or maximize. When you see either one of these words in a problem with a quadratic, which is a x to the square, when you see minimize or maximize with the quadratic, you will find the vertex. Finding the vertex will answer these questions. What will end up happening is x, the x coordinate usually answers part A because x is the number of bikes, and the y coordinate will answer part B because the y coordinate would answer the part about the cost, because this is the cost function. So the number of bikes that you need to make is the x. You plug in the x in this function, you will get the cost. That is what you get when you plug in part A into this function, then you get part B. So that's the strategy. We're going to find the vertex. The x coordinate answers part A. The y coordinate will answer the part about the cost. So let's find the vertex. So in this vertex, in this formula here, function, so we're going to find the vertex. The A is 2, and the B is negative 800. So we are going to use this information and find the answer to this. So, vertex formula is, again, negative B over 2A and F of negative B over 2A. So again, whatever answer you get for the S coordinate, plug it back into the function, you get the Y coordinate. So we're going to use negative, and B is negative 800. So there's your minus B over 2, and A is 2. So all of this is going to be used to find the X coordinate of the vertex. So this becomes 800 over 4. Okay, so I'm running out of space. Let me just let me do that. So when you divide the 800 by the 4, we get 200. So 200 is going to represent the number of bikes that must be made to minimize the cost. So when you find your X part of the vertex, That answers the part about the number of bikes that must be made. So if it's 200, then I'm gonna put 200 here because that is going to be the number of bikes that must be made to minimize the cost. So what is the minimum cost? So now we are going to plug this 200 into this equation. So I'm going to write a comma here because when I work this out, this is going to be the y coordinate of the vertex. So again, we're finding out the cost of making 200 bikes, the cost of 200 bikes. So I'm putting in 2, and I'm plugging the x here. 200 squared minus 800 times 200 plus 92,000. So this is what I'm going to have to work out to find the answer to that question. Oops, I'm going to have to blow away here. So what we're going to do is, so this is 200 squared is 40,000 times 2. This 200 squared, 200 times 200, 40,000. 40,000 times 2, 80,000. Minus, so 800 times 200 is 160 with 4 zeros. So that's 160,000 plus 92,000. So when I keep on working this out, I'm going to get, this is minus 80,000 right here. Minus 80,000. And then let's see, plus the 9,200. Okay, and it's 80,000, right? Plus 9,200. And so when I work all this out, I'm going to get 12,000. So this 12,000, all of this is my y coordinate of the vertex. So this answer is part A. How many bikes? 200 bikes. Right here, 200 bikes we got from the x coordinate of the vertex. And that answer is part A. And then what is the cost? So the number we got here, we plugged it right back into this equation. And we take our time. We do the order operations. We do 200 squared, we get the 80,000. We multiply 800 times 200, 160,000. Add it to 92,000. We make our subtractions here. We're going to add to 92,000. And when we do our math here, we get 12,000. So this 12,000 is the cost. So that's part B. And part B wants you to find the cost. So this answer is B. The answer to B is 12,000. Because that was what we got when we plugged in the X value into the vertex. So I realize that's a lot of numbers, a lot of things to internalize, but the main thing to remember is minimize or maximize. We use the vertex formula. The vertex formula is this minus B over 2A. f of minus b over 2a. And this answers the first part of the questions, and the y coordinate answers the second part. So this was the number of bikes, and this was the cost to minimize. So yeah, I mean that's it's a decent amount going on here, but the main key is right here. The vertex formula answers these questions. Just make sure you put in the right value for A, put in the right value for B. When you input them in, the X value answers the number of bikes, and the B value, plug it into that, and that answers the cost to minimize. So like Erica says, you get that a minute to let that sink in, as she put it. I like to say marinate. Let that marinate for a moment. And I would like to try another similar kind of problem. After you let that marinate for a moment. So while you do that, let me write out this other one here. It's a very similar type of problem. So hopefully that's kind of marinated a little bit. Let's just try another one. It's very, very similar. So a company determines that its daily revenue for selling X units for a product is modeled by this function. And this function is R of X, R for revenue, negative X squared plus 110X. So question A, what number of units must be sold in order to maximize the revenue? That's question A. And question B, what is the revenue? So before you get started, please note that we have the key word, in this case, maximize. So when we see maximize, we are going to, I saw your work there in the chat. Thanks for that, Elsa. Maximize or minimize, we use the vertex formula. So I would like you all to take a few minutes, please, on your own. Let's see how far you can get using the vertex formula for this function. Keep this in mind. In this function, A equals -1 and B equals 110. So it's 417 at 420. I want to see how far we've gotten. If you have an answer by 420, put your answers in the chat. See how far we can get in by 420. $4.20. Okay. How far did we get any answer? Nothing in the chat? Did you try this, Elsa? How far did you get, Elsa?
I'm almost done.
Oh, okay, okay. I'm gonna give you a minute there, Elsa. I'd like to get at least one answer. That would be good. I'm really looking forward to one answer at least. Oh, hey, Mike. Okay, now, Mike, that 55, that's to be positive. That's to be a positive 55. Okay, so that's good. The first part is 55. Yes. Good, good, good. Now, what they want to do is they want to maximize the cost. That means the cost should be a nice positive number, Mike. So if we're maximizing the cost, we don't want to see anything negative. That means that your business model is going to crash and burn if you're trying to maximize the cost and you get a negative value. But it's okay. Let's work this out. Let's work this out. Anybody else? This Mike and Elsa. No one else? Okay. That's okay. That's all right. Oh, you know what? I did forget to take attendance. I need to do that. I need 1 minute for that. I need 1 minute for that. Hold on. Just give me 1 second. It's important that I get this attendance in here. It's coming up in just a moment. Spinning. I think I saw Dami Lola here, didn't I? Let's see. I did see Dami Lola. Anyway, I saw Olu, Elsa. I see Destiny, Kathy, Mike. I saw Morris. I think, did I see Maya? Well, let me go back. Do I see Maya? Yes, I do. Okay,
So,
thanks,
Professor,
Maya.
the first one I had 55. We're still working on the second one.
Okay, 55. Yes, that's good. Yes, yes, yes. So yes, the first part A should be 55. So let's go over how we got 55. Let me close this up for a second. Okay, so to get 55, so we know the vertex formula. Let's go over that again. Is minus b over 2a, and the second part is negative, is f of minus b over 2a. A is minus 1, b is 110. So we have minus, and then b is 110 over 2 times negative 1. So again, this is the x coordinate of the vertex. So that's minus 110 over minus 2. So the x coordinate of the vertex should be 55. That's how they got 55. So the number of units that must be sold in order to maximize the revenue. And again, it says here that X is the number of units, X units for a product. So the answer to part A is 55. 55, okay? Now, the second part is 2. So the revenue for 55 units, the revenue for 55 units, that's gonna be our Y coordinate. So when we do this, negative sign, put the 55 in parentheses, 55 in parentheses, plus 110 times 55. So what will happen is we have to take this 55 and square it. So when we square the 55, I get 3,025. Next thing, plus sign, I'm gonna take the 110 and multiply that by 55, because again, everywhere I see 55, I'm putting in 55 here, 55 here. So when I multiply these two, I get 6,050. Then when I combine these two, I get the cost, I get the revenue of this being positive 3,025. So that's what will go here as the Y coordinate of the vertex. So this would be what my revenue is. It's positive. You want the revenue, if it's maximized, you certainly want the revenue to be positive. So what is the revenue? It's $3,025.
I'm sorry, Professor. Professor.
Yes, Olu.
Yeah, I have a question.
Yes,
Where
yes.
we have the negative 55 raised to power 2, I was thinking that the negative down here, we're not gonna have it anymore since it's the square root of what's it called? 55. Oh, I think I understand. Never mind.
Well, just so we are on the same page. So when this is the function here, and when you find your x value, when you plug it back into this function, make sure you put that value in parentheses. Put that value in parentheses. So when you follow the order operations, you're going to square this 55 and then multiply that by the negative sign. So that's why this is negative here. Some of you may have
Okay,
made,
Professor.
some of you may have made this positive. I'm not sure. But whatever value you get for the x, when you plug it back into the equation, make sure you put it in parentheses so that when you square it, then this answer you multiply by that minus sign, and that's why this is a negative sign here. And then when you combine these two together, you get this positive revenue value. I guess I should put dollar signs here. This is all revenue. This is all money. This is all money. So this answers the 55 answers part A. And this 3,025, that's the maximum revenue. That's part B. One is part A, one is part B. Maybe make it a little bigger to see. Part A, part B. You have just a couple of problems like this, just so that you are familiar with it. This is the last thing I was supposed to cover. Just using the vertex formula. This is all the vertex formula in a quadratic application. Anytime you have something to the second power, that's a quadratic. We have a quadratic in the word maximize or minimize. That means you find the vertex. And since we have a few minutes left, I wanted to take the time to do one more graph. Let's get used to this graph. One more quadratic graph. One more parabola. One more parabola. All right? And that will be all we do today. And then Friday, we'll review. Monday, we'll review. And again, 1 week from today is a final exam. I think it's 20 questions. I'm going to say it's 20 questions. Pretty sure that's what it is. So here's one more last parabola to graph. Let's try this. X squared minus 6x minus 7. So we're going to graph this. Now, what do we need to graph a parabola? We need three things. What's the first thing we need?
Vertex.
The vertex.
Awesome. Second thing.
X-intercept.
Thank you. Now to get the x-intercept, we set y equal to 0 and factor. Let's keep that in mind as well. The third thing we need?
Y-intercept.
Y-intercept, which we find by setting the x to 0. And again, the vertex formula is minus b over 2a, and then the function at minus b over 2a. In other words, whatever answer you get in part A for the x, plug it into the function, you get part B, and together you get the vertex because the vertex is an ordered pair. So in our example up here, A is 1, B is -6. So for our vertex, it is minus, and B is -6. So it's minus -6 over 2 times 1. So this is positive 6 over 2. So your vertex, the S coordinate is 3. That's your X coordinate of the vertex. Now to find the Y coordinate of the vertex, we're going to plug 3 into the places where we see the X. So I'm going to put in 3 squared minus 6 times 3 minus 7 to get this Y value of the vertex. 9 minus 18 minus 7. So to work this out, that's negative 9 minus 7. So the Y coordinate is negative 16. So the vertex is 3 is your X coordinate. And when we plug this in and work this out, we got negative 16 as the Y coordinate. So there's your vertex. And I'm going to put all this on one graph at the same time. So just hold on to this. Then we're going to find the x-intercept. So part 2 is the x-intercept. To find the x-intercept, we're going to, again, set y to 0 and factor. So here's our equation. I'm going to make this y 0. I'm going to write the rest of this, x squared minus 6x minus 7. So I'm going to factor this. 2 parentheses, x here. So I'm looking for a pair of numbers multiplying to 7 and adding to negative 6. Those numbers are,
And how you go about getting those numbers again? You said they multiply to 7 and add to negative 6.
correct.
How you do that?
Yeah, how do you do that? How do you get numbers that multiply to this and add to this?
All right, let me think.
6 and 1.
6 and 1
Right.
won't multiply to this. It has to multiply to this.
I guess you can't.
Yes, wait, what will multiply to this and add to this?
7. Second. All right, let me think about it.
7 and 1, and what should these signs be?
Let's
What's going to add? What's going to add to a minus 6?
Wait.
Minus
Oh, subtract.
and
And
plus.
plus. Negative 7 and 1, that'll add to negative 6, right? And these will multiply to minus 7. So once you have a factor, you take your x minus 7, set that equal to 0, your x plus 1, set that equal to 0. When we add 7, that gives us one of the x-intercepts. When we subtract 1 minus 1, that gives us the other x-intercepts. So here's our vertex. Here's our x-intercepts. And then before we graph, the last thing we need is the y-intercept, which we get by setting your x equal to 0. So our equation, our original equation, was x squared minus 6x minus 7. We're going to set the x to 0. So that's 0 squared minus 6 times 0 minus 7. So our y-intercept, that's 0, 0, minus 7. There's our y-intercept. So now we have what we need. Vertex, x-intercepts, y-intercept. So let me draw a graph. Make it neat for you. Okay. We know the x and y's, of course. So the vertex is 3, comma, negative 16. Whoa, way down here. Okay. So 3, negative 16, that's down there. Here's our vertex. Then what else did we get? We got the y-intercept 7 and negative 1. So there's our 7. There's our negative 1 and our 7. There's our vertex. And the last thing we wanted was the y-intercept, negative 7. Right here. So you see how we're going to draw our parabola. So let's draw as neatly as I can. Here's that. And then we're going to make a nice little loop right through there. That's good. So that would be the sketch of the parabola. So we have covered 100% of the course. Very good. So happy for your attention and your
Professor,
diligence.
can I see the y-intercept again?
I appreciate your attention and your hard work, your diligence, your attendance, your best efforts. And we will review the next couple of days. If you have other questions, anything